Hi, we're the Maryland UAS team.
Hi, my name is Joshua Gauss. I'm a senior at the University of Maryland studying mechanical engineering. I've been on the team for 3 years. I have extensive prior experience with model aviation. At the flight line, I will be fulfilling the role of safety pilot. However, my roles on the team are team lead, safety pilot for our testing, and sub-team lead of the flight system subteam.
Hi, my name is Eric Thompson. I am a senior aerospace engineer. I am the autopilot lead for the team, and on the flight line, I will be the main ground control operator. My experience, I've worked with UAS systems for a number of years. I currently work in the Unmanned Systems Research Laboratory at the University of Maryland, and I enjoy applying all types of things.
I'm Matthew Vaughn. I'm a senior studying aerospace engineering, and I've been on the team for 2 years. I've worked on various robotic navigation projects, from small ground vehicles to UAVs to rockets, generally on the software side. On our UAS team, I developed an obstacle avoidance algorithm based on the algorithm called D-Starlight. On the flight line, I will be available in the event that there's a software malfunction that needs to be fixed for the second run.
Hi, I'm Katie John. I'm a senior studying mechanical engineering at the University of Maryland. I've been on the team for 3 years and I'm the imaging team lead. I have some prior experience with programming small robotics projects and conducting research for other teams on UAV payload systems. For the flight line, I will oversee that our procedures are followed, provide the pre-flight brief, and be backup for imaging.
Hi, I am Peter Merneb, and I'm a freshman studying mechanical engineering and computer science. I've been on the MUAS team for 9 months and have had some experience with robotics in the past. This year, I've been working with the imaging subteam to improve the object detection and classification algorithms. On the flight line, I will be the imaging lead operator, working to ensure that the imaging system is working properly.
Hi, I'm Howard Hugh, a junior studying computer engineering. I have been on this team for roughly 8 months. I have had previous experience with programming Arduinos and Romeo boards. I am currently part of the communications subteam, where I work on communicating with the judges server and getting a wireless connection to the plane. For our flight line, I will be the plane tracker and communications backup.
Hi, I'm Raymond Kohler. I'm a junior mechanical engineering major, and I've been on the UAS team for 3 years now. All my experience in UAS technologies has been gained through this team. I am currently in training to be the safety pilot, and I will be the visual observer and...
Hi, my name is Nathan Hoffman. I'm a mechanical engineering major at the University of Maryland, and I just finished my sophomore year. This will be my second year on the team, and on the flight line, I will be the judge liaison.
So this is our team's vehicle. It's a ready-made RC Anaconda airframe. We're using the servos, motor, and speed control that are included with the Almost Ready to Fly kit. We've painted it ourselves, but most of the modifications that we've done to this aircraft are cutting holes in the bottom to allow the camera gimbal and payload drop to have access below the aircraft, and also an interior structure that holds all of our components in place. In terms of the externals, it's a slightly unconventional inverted V-tail aircraft with a pusher prop, conventional ailerons, leading edge slats, and flaps.
For this year's competition, we will be attempting all categories. We have about a 95% confidence level that we can complete the autonomous flight, both takeoff, navigation, and landing. We have a 75% confidence level in our obstacle avoidance abilities, both stationary and moving. We have 75% confidence in our object identification and classification, but a 95% in the manual backup for object recognition, and a 75% confidence level that our air delivery system will work as predicted.
Our vehicle is able to autonomously navigate through the autoplane flight stack. This, along with motion blender, allows us to accurately navigate waypoints and autonomously replan. Through testing, we have found that our system can reliably navigate within 18 feet of a desired waypoint. In order to complete obstacle avoidance, our vehicle uses Mission Planner's replanning ability along with the path planning algorithm D-Star Lite to plan around obstacles in the vehicle's path. The algorithm localizes where it predicts the moving obstacles will be to plan an efficient route around them. On average, the new path can be computed and uploaded to the vehicle within 0.7 seconds. During our testing, the vehicle was able to avoid all the obstacles between waypoints in 8 of 11 created test scenarios.
We will complete the image recognition task at 150 feet altitude approximately. This gives us a resolution of 2.5 pixels per inch, which gives us sufficient resolution to identify the character within the image. For the image detection, classification, and localization task, we took prior images and ran them through our algorithms to determine whether they met each criteria. We found that 8 out of 10 of the images found the region of interest correctly, 8 out of 10 isolated the shape, 4 out of 10 identified the shape correctly, 8 out of 10 isolated the character, 3 out of 10 identified the character correctly, and then the color, orientation, and location are manually determined by a human operator. This is a video of one of our air delivery performance tasks. We dropped the water bottle from the aircraft, aiming for the 10 on the end of the runway. As you can see in the upper right photo, the water spilt out of the bottle, and it came pretty close.
For our full mission tests, we tested the aircraft twice. This included autonomous takeoff and landing, waypoint following, autonomous imaging of the target area, transmission of pictures from the aircraft to the ground whilst in flight using our communications network, manually classifying the targets that we found, automatically dropping the payload onto the payload drop target, transmission of telemetry and pictures to the judge's server through Mavlink and Ethernet connections respectively, and autonomous avoidances of obstacles.
Previous iteration full mission tests exposed a couple of problems with connectivity and payload access, so we added extra redundancy to the communication system and improved payload access. Based on our initial performance in our flight tests, we estimate that we will earn a score of around 65 out of 80 for the mission performance component. Thank you for your time, and we look forward to competing.